Hello, friend. Welcome to Science for Sleep. Tonight, we begin with something both common and mysterious. A moment that has likely visited you at least once, even if you did not try to summon it. About half of all people will experience a lucid dream at least once in their lifetime. Not because they practiced, not because they studied sleep, and not because they were searching for it. It simply happens. A lucid dream is not rare. It is not supernatural. It is not a story layered on top of sleep after the fact. It is a real, measurable brain state that unfolds most often during rapid eye movement sleep. It is a stage of sleep where the brain becomes highly active. The eyes move quickly beneath closed lids, and most vivid dreaming takes place. During this stage, the body remains still due to a natural muscle lock, even while the mind builds entire worlds. After this point, we'll call it REM. A lucid dream begins in the same place as any other dream. The world forms quietly. Scenes appear without effort. Faces, landscapes, conversations, impossible physics. The brain builds an entire environment from memory, imagination, and stored fragments of experience. And then something unusual happens. Instead of moving through the dream automatically, a thought appears. This is a dream. You are still asleep. Your body has not moved. Your eyes remain closed. The brain is still in REM, but awareness has shifted. Lucidity does not mean the dream disappears. It does not mean the room around you fades in. It does not even mean you gain control. In fact, this is where many people misunderstand the experience. You can be aware without controlling the dream. You may recognize you are dreaming, and yet the story continues on its own. The characters keep speaking. The environment keeps unfolding. You stand inside it, aware, but not necessarily directing it. Awareness and control are separate systems. And here is where the science becomes quietly fascinating. In sleep laboratories, researchers once asked trained lucid dreamers to prove they were aware while asleep. During REM, most of the body is held still by a protective system called muscle atonia. The brain prevents you from acting out the dream, but the eyes are different. They can still move. So the researchers instructed the dreamers to move their eyes left and right in a specific pattern once they realized they were dreaming. When those dreamers entered REM, the machines recorded the usual sleep signals. And then suddenly, a deliberate left-right eye movement appeared. Clear, distinct, intentional. The dreamers had not woken up. Their brain patterns still showed REM. They were asleep. They were dreaming. And they knew it. That experiment changed how lucid dreaming was understood. It showed that awareness can exist inside sleep, that the brain does not fully shut down self-reflection during REM. Instead, under certain conditions, parts of the brain involved in monitoring and awareness become more active. Lucidity often feels like a small light turning on inside the dream. Not a spotlight, not a flood of clarity, just a lamp. Sometimes it lasts only seconds before fading. Sometimes it strengthens. Sometimes it flickers on and off within the same dream. It is not an all-or-nothing switch. It is a spectrum. And if you enjoy these quiet journeys into how the mind works, you're welcome to subscribe. And if it feels natural, to leave a comment sharing where you're listening from tonight. It helps others find their way to this calm corner of the world, one sleepy traveler at a time. The quiet continues here, just as it is. Over the course of this exploration, we will gently map the architecture of sleep itself. We will look at how REM cycles rise and fall across the night. We will explore which parts of the brain grow quieter during ordinary dreaming, and which parts briefly return during lucidity. We will follow the chemistry of acetylcholine and dopamine, and the protective stillness of muscle atonia. We will look at eye signals recorded in dark sleep labs, and at the delicate boundary between dreaming and waking. For now, you can simply picture it. A sleeping brain, deep in REM. Images forming without effort, emotion coloring the landscape, and somewhere inside that shifting world, a quiet recognition. This is a dream. It's like a small lamp turning on inside a world made of sleep. Before we talk more about lucidity, we need the simple roadmap of a normal night. Sleep is not a flat stretch of darkness. It moves in cycles. Each cycle lasts about 90 to 110 minutes, and most adults move through 4 to 6 of these cycles before morning arrives. The night rises and falls in waves, steady and repeating. When you first fall asleep, you enter a light stage called N1. Thoughts loosen, muscles soften. The outside world begins to fade. It is a thin layer between waking and deeper sleep. Soon after, you drift into N2. This stage makes up a large part of the night. Brain activity slows in places, then briefly bursts in small patterns called sleep spindles. Your body temperature drops slightly. Your heart rate becomes steadier. The mind is settling. Deeper still is N3, often called deep sleep. Brain waves become slow and powerful. The body repairs. Growth hormone is released. This is the stage that feels hardest to wake from. If someone calls your name during N3, it can feel like climbing out of a deep pool. But sleep does not stay in deep stillness all night. After moving through these stages, the brain enters REM sleep. From this point forward, we'll call it REM. The first REM period of the night usually arrives about 70 to 90 minutes after you fall asleep. It may be short, perhaps only 10 minutes. Then the cycle begins again. Back through lighter sleep. Sometimes deeper sleep returns. And then REM comes again. As the night continues, something interesting happens. The deep N3 sleep becomes shorter. The REM periods become longer. By early morning, REM can last 30 to 60 minutes at a time. This is one reason dreams often feel more vivid or more complex, closer to waking. During REM, the brain becomes active in a way that looks surprisingly similar to waking on an EEG recording. The waves are faster and less synchronized than in deep sleep. Yet the body remains still, protected by muscle atonia. Breathing becomes less regular. The eyes move quickly beneath closed lids, scanning the dream world that only the brain can see. Dreaming can happen in other stages too, but the most vivid, story-like dreams are strongly linked with REM. The brain areas involved in emotion and imagery are especially active during this stage. The mind becomes creative, fluid, unconstrained by the usual rules of waking logic. Across the night, these cycles repeat with quiet rhythm. Light sleep, deeper sleep. REM again and again, like tides rising and falling. Each cycle slightly different from the last. This structure matters because lucid dreaming does not float randomly through the night. It most often emerges during REM. And because REM grows longer toward morning, lucid dreams are statistically more likely during those later cycles. It is not that the brain suddenly becomes magical at dawn. It is simply that REM is lasting longer. There is more time for dreams to form, more time for awareness to briefly return. For now, you can picture the night as a gentle series of waves. You fall asleep, you drift downward, you rise into REM, you return again. 4, 5, maybe 6 times before morning. Deep sleep early, longer REM near dawn. A shifting pattern that repeats with soft consistency. Lucid dreaming lives inside this rhythm. It is not separate from it. It is not outside it. It is a variation within the same structure that carries you through every night. A night of sleep isn't flat. It's more like waves that keep returning. Dreams can feel like real life, even when they are impossible. You might be standing on the surface of the ocean, walking through a house that no longer exists, or speaking to someone you have not seen in years. The sky may shift colors. The laws of physics may bend quietly in the background. And yet, while you're inside the dream, it rarely feels strange. It feels normal, convincing, real enough that you move through it without hesitation. To understand why this happens, we need to slow down and look carefully at what the brain is doing during REM. During REM, the brain becomes highly active. On an EEG recording, the electrical patterns look surprisingly similar to waking. The waves are fast and mixed, not slow and heavy like deep sleep. This tells us something important. The brain is not off during REM. It is awake in many ways, even while you are fully asleep. One of the most active regions during REM is the visual cortex, located near the back of the brain. This is the same region that processes what your eyes see during the day. But during REM, your eyes are closed. There is no light entering from the outside world. Instead, the brain is generating its own imagery from stored memories, fragments of experience, and creative recombination. It is as if the brain is projecting a film from the inside, using its own archive. At the same time, emotional centers such as the amygdala become active. The amygdala plays a key role in processing emotion, especially feelings like fear, excitement, surprise, and intensity. This helps explain why dreams can feel emotionally amplified. Small events can feel urgent. Neutral scenes can feel meaningful. A minor shift in a dream can feel important. So during REM, 2 powerful systems are strongly engaged. The system that creates vivid imagery and the system that generates emotional tone. But something else is happening quietly in the background. Certain areas in the front of the brain, especially parts of the prefrontal cortex, are less active during normal REM. These regions help with logic, planning, self-reflection, and reality checking during waking life. They are the parts of the brain that ask questions like, does this make sense? Or, is this possible? When those systems are quieter, the dream unfolds without being challenged. If a staircase suddenly leads into the sky, you climb it. If a friend changes into a stranger mid-sentence, you continue the conversation. If you find yourself breathing underwater, you accept it as the new rule of the world. The brain is not comparing the dream to outside reality. It is operating within its own internally generated environment. This balance, high visual and emotional activity, combined with reduced logical monitoring, creates the feeling of immersion. The dream does not feel fake because the systems responsible for detecting inconsistency are softened. The imagery is vivid. The emotions are strong. The critical filter is gentle, and so the experience feels real. It is not that the brain is confused. It is that the brain is running in a different configuration. In REM, memory fragments are combined in flexible ways. Scenes can shift because they are not anchored to physical sensory input. There is no stable stream of outside information to correct the story. The brain becomes both author and audience. For now, picture the sleeping brain again. The body rests under the steady hold of REM atonia. The room remains still, but inside, networks are alive with activity. Visual regions fire without light. Emotional circuits hum quietly. Memory traces connect in new patterns. And without the full strength of logical evaluation, the mind accepts the world it builds. In REM, your brain can create an entire reality, and you usually accept it. Even if your dream body is running, your real body stays still. During REM, the brain activates a powerful protective system known as muscle atonia. The word sounds complex, but its meaning is simple. Atonia means a loss of muscle tone. In this case, it is a temporary and intentional softening of most voluntary muscles. It is not weakness. It is not damage. It is a carefully regulated pause. When REM begins, networks in the brainstem send signals downward through the spinal cord. These signals reduce the ability of motor neurons to activate the large skeletal muscles of the body. The arms do not lift, the legs do not step, the torso does not twist. The muscles are quieted before they can carry out movement commands. At the same time, the brain is highly active. Visual systems are generating imagery. Emotional centers are engaged. Memory fragments are being woven into scenes. Inside the dream, you may be climbing, swimming, running, or reaching. You may feel motion vividly, but the body remains still in the bed. This system exists for protection. If REM did not include muscle atonia, many dreams would become physical actions. A sudden jump in a dream might cause a real leap. A defensive movement might lead to injury. The nervous system prevents this by separating dream movement from physical movement. The brain runs the simulation. The body remains at rest. There are a few exceptions to this stillness. The diaphragm continues to move so that breathing can occur. The heart continues to beat, and the muscles that control the eyes remain active. The rapid eye movements beneath closed lids are one of the defining features of REM. These movements are visible on sleep recordings and are thought to relate, at least in part, to the scanning of dream imagery. But the larger voluntary muscles remain inhibited. Importantly, lucid dreaming does not remove REM atonia. Becoming aware inside a dream does not reactivate the body. The brain remains in REM. The chemical state remains REM-like. The muscle inhibition remains in place. You may know you are dreaming. You may attempt to move within the dream world, but your physical muscles remain quiet. This tells us something essential about lucidity. Lucid dreaming is not waking. It does not replace the REM state. It is awareness emerging within it. The protective motor system continues to function exactly as it does in ordinary REM dreaming. Sometimes, however, the timing between brain systems can briefly overlap in noticeable ways. If awareness returns while REM atonia is still active, a person may experience sleep paralysis. In sleep paralysis, the mind feels awake or partially awake, but the body cannot move. The room may feel present. Sounds may be perceived. Yet the muscles remain under the same inhibitory control that protected the body during REM. This experience can feel intense if unexpected, but physiologically it reflects a temporary overlap. The REM motor lock lingers, while consciousness rises, usually within seconds or a short minute. The inhibition fades and movement returns naturally. There is also a rare sleep disorder called REM behavior disorder, often abbreviated as RBD. In this condition, the muscle atonia that normally occurs during REM is reduced or absent. Without the motor inhibition, individuals may physically move during dreams. They may speak, gesture, or enact dream behaviors. This condition is uncommon and is associated with changes in the brainstem systems that regulate motor inhibition. The existence of RBD highlights how reliable and important REM atonia normally is. Night after night, without effort or awareness, the brainstem engages this system. It protects the body while allowing the mind to simulate movement freely. The coordination required for this separation is precise. The brain must generate vivid imagery, activate emotional circuits, and produce rapid eye movements, all while simultaneously blocking most voluntary muscle output. It is a layered process. One system constructs the dream. Another system prevents the dream from becoming physical action. Inside REM, the body and the dream are running on separate tracks. The dream body can move through landscapes, open doors, lift objects, and travel great distances. The physical body remains quiet, supported by the bed, breathing steadily. Even in lucid dreams, where awareness flickers on, this separation remains intact. You may realize you are dreaming while floating through the air. You may attempt to change direction or alter the scene. But beneath it all, the motor lock continues. The arms stay still. The legs remain at rest. This protective stillness is not something you feel directly. It operates beneath awareness. It is one of the many quiet systems that make sleep safe. Across the night, as REM cycles lengthen toward morning, this motor lock returns again and again. Each time REM begins, the brainstem engages the inhibition. Each time REM ends, the muscles gradually regain their tone. The rhythm is steady. The mind explores. The body rests. The dream can move freely, while your body rests safely. Let's slow down and look at the brain's sleep recipe. Sleep may feel quiet from the outside, but inside the brain, it is carefully coordinated chemistry. Different stages of sleep are defined not only by electrical patterns, but by shifts in neurotransmitters, the chemical messengers that allow brain cells to communicate. During REM, the brain runs on a distinct chemical balance. This balance is different from waking life and different from deep sleep. It is not random. It is regulated by networks in the brainstem that control when certain chemicals rise and fall across the night. One of the most important neurotransmitters during REM is acetylcholine. Acetylcholine levels rise significantly during REM. In some regions, they approach levels similar to waking. Acetylcholine supports attention, learning, and the activation of sensory regions. When acetylcholine is elevated, the brain becomes capable of generating detailed internal imagery. This helps explain why REM dreams often feel vivid and immersive. The visual cortex becomes active even though the eyes are closed. Memory fragments are reactivated. Scenes are constructed from stored experiences. Acetylcholine supports this internal activation, allowing the brain to simulate a world without outside input. At the same time, other neurotransmitters decrease. Serotonin, which plays a role in mood regulation and steady cognitive processing, drops to very low levels during REM. Norepinephrine, which supports alertness and external vigilance, also falls. During waking life, these chemicals help stabilize thinking and maintain consistent focus. When they are reduced, the brain becomes less anchored to external reality. With serotonin and norepinephrine quieted, the mind becomes more flexible. It moves between ideas without strict correction. Associations form more loosely. This contributes to the unusual logic of dreams. A hallway can turn into a forest. A conversation can shift without explanation. The brain is not actively comparing the dream to the outside world. Instead, it is operating within its own internally generated environment. Dopamine, another neurotransmitter, appears to remain active during REM. Dopamine is involved in motivation, reward, and novelty detection. Some researchers suggest that dopamine activity may contribute to the intensity or significance certain dream moments can carry. It may help explain why events in dreams sometimes feel meaningful or heightened, even if they are not logical. Together, this chemical pattern creates a very specific internal state. High acetylcholine supports vivid imagery. Low serotonin reduces strict monitoring. Low norepinephrine decreases external vigilance. Dopamine contributes to flexibility and emotional tone. This combination does not produce confusion. It produces immersion. The brain becomes internally focused. It generates scenes from memory and imagination. Emotional centers remain active. Logical oversight softens. The result is a state where the dream feels complete and convincing from the inside. Lucid dreaming occurs within this same chemical environment. When lucidity appears, acetylcholine is still elevated. The brain is still in REM. Muscle atonia remains in place. The emotional and visual systems continue their activity. What changes is not the overall chemical recipe, but the activity pattern within certain networks linked to self-awareness. In other words, lucidity does not replace REM. It emerges inside it. Some laboratory studies have explored whether altering this chemistry influences lucid dreaming. Substances that increase acetylcholine levels, such as galantamine, have been tested under controlled conditions. In certain experimental settings, when combined with cognitive techniques, increasing acetylcholine has been associated with higher rates of reported lucid dreams compared to placebo. This does not mean chemicals alone create lucidity. but it does reinforce the idea that the REM chemical environment plays a central role in dream vividness and the potential for awareness to emerge. Across the night, these chemical shifts follow a rhythm. Deep sleep dominates earlier hours, when acetylcholine is lower and slow-wave activity is strong. As morning approaches, REM periods become longer. Acetylcholine rises again and again in cycles. The internal recipe changes with each wave of sleep. Inside this rhythm, the brain constructs entire experiences without sensory input from the outside world. Light is not entering the eyes. Sound is not driving the imagery. Movement is not guiding perception. Instead, neurotransmitters shift. Networks activate. Memory fragments combine. The brain is not off during sleep. It is running a different settings menu. So what changes when lucidity appears? A dream is already active during REM. Images move, emotions rise, scenes shift without warning. The brain is building an entire world from the inside. And yet, in most dreams, you move through that world automatically. You do not question it. You do not reflect on it. You simply experience it. Then sometimes, something different happens. You notice. Lucidity is linked to what scientists call meta-awareness. Meta-awareness means noticing your own mental state. It is awareness turned inward. It is the ability to think, I am thinking. Or in this case, I am dreaming. During normal REM, the parts of the brain involved in metacognition are usually quieter. Metacognition is the ability to reflect on your own thoughts and experiences. It allows you to evaluate what is happening and compare it to memory or logic. When those networks are less active, the dream continues without interruption. But in lucid REM, this pattern shifts. Brain imaging studies and EEG recordings suggest that certain frontal and parietal regions become more active when lucidity appears. These areas are associated with self-reflection, monitoring, and higher-level awareness during waking life. In ordinary REM dreams, emotional and visual regions are strongly engaged. The amygdala is active. The visual cortex generates imagery. Memory fragments combine freely, but the prefrontal cortex, especially areas involved in evaluation and reflection, is relatively subdued. Lucidity seems to involve a partial reactivation of these regions. It is not a full return to waking consciousness. The brain does not fully shift out of REM. The dream continues. The imagery remains immersive. The body remains under REM atonia. But certain networks linked to self-awareness increase their activity. Some EEG studies have found higher frequency brain activity during lucid REM, including increased gamma or beta band activity compared to non-lucid REM. Higher frequency activity is often associated with conscious processing and cognitive integration. While research in this area is still developing, the pattern suggests that lucidity may involve a more coordinated or synchronized state between brain regions. In simple terms, parts of the brain responsible for reflection and monitoring become more engaged. That engagement allows a new thought to form inside the dream. This is not waking life. This is a dream. It is not that the dream world changes first. It is that awareness changes. The brain is still generating imagery. The emotional tone is still present. But now the mind observes itself. It recognizes its own creation. This is why lucid dreaming is often described as a hybrid state. It is not fully waking. In waking life, the brain is anchored to sensory input. You feel the room. You hear subtle sounds. You can move freely. In lucid dreaming, those anchors are absent. The environment remains internally generated. But it is not ordinary dreaming either. In normal REM, self-reflective awareness is usually reduced. The dream unfolds without evaluation. In lucid dreaming, that evaluative layer returns, not completely, but enough to notice the state. A hybrid, dreaming with a touch of waking-like awareness. The switch into lucidity is not dramatic from the outside. The EEG still shows REM. The body remains still. The eyes may continue their movements beneath closed lids. But inside the experience, there is a shift. It can feel like clarity sharpening slightly. The colors may appear brighter. The scene may feel more stable for a moment. Or the realization may come quietly, without any change in visuals at all. Lucidity is not always loud. It can be subtle. And it is often fragile. Because the brain is still in REM. The networks that support ordinary dreaming are still active. The emotional systems remain strong. The logical systems are only partially re-engaged. Awareness can fade. The dream can pull the mind back into automatic immersion. The hybrid state is balanced delicately between reflection and absorption. When reflection strengthens, lucidity deepens. When absorption takes over, lucidity fades. Researchers continue to explore exactly how these networks interact. The precise mechanisms are still being mapped, but the broad pattern is consistent. Lucidity corresponds with increased activity in regions associated with self-awareness and monitoring. It is not a separate state inserted into sleep. It is a variation within REM. The dream continues. The imagery persists. The body rests. But now, within that internally generated world, a new layer appears. Recognition. A lucid dream is still a dream, but with a small return of self-awareness. Think of it like the manager part of the brain briefly returning. During ordinary REM dreaming, the brain is active in many regions. Visual areas generate imagery. Emotional centers create tone and intensity. Memory systems combine fragments into scenes, but the parts of the brain responsible for reflection and evaluation are comparatively quieter. These regions are located mostly toward the front of the brain, in areas often grouped under the prefrontal cortex. During waking life, the prefrontal cortex helps you plan, evaluate, make decisions, and reflect on your own thoughts. It helps you ask questions like, does this make sense? Or, is this possible? In normal REM, this manager system is less engaged. The dream flows without supervision. But imaging work suggests that during lucid REM, parts of this frontal network increase their activity. Studies using brain imaging and electrical recordings have shown greater activation in frontal and parietal regions when people report being lucid inside a dream. The parietal areas are involved in spatial awareness, and the sense of self in space. The frontal areas support self-reflection and monitoring. One region that appears frequently in lucid dreaming research is the anterior prefrontal cortex. This area plays a role in meta-awareness and in comparing mental states. During waking life, it helps you reflect on your own thinking. It supports the ability to notice your own internal experience. In ordinary REM dreams, this region tends to be less active. The dream feels immersive because it is not being monitored closely. You experience events directly without stepping back from them. In lucid REM, the anterior prefrontal cortex appears to become more engaged. This does not mean it is fully awake. It does not mean all waking-style reasoning returns. But its increased activity may provide enough monitoring to allow a simple but powerful realization. I am dreaming. Normal REM dreams are often emotional and visual, but less self-reflective. You may feel fear, joy, urgency, or curiosity. You may see detailed landscapes or shifting environments, but you rarely evaluate the dream from outside the experience. Lucid REM is different in this specific way. The dreamer begins to reflect. The frontal networks, even if only partially reactivated, provide a sense of perspective. Instead of being fully absorbed in the narrative, you step slightly outside it. You observe it. It is similar to watching a movie and suddenly remembering you are in a theater. The screen continues, the characters continue, but awareness shifts. This shift can feel sudden. A person might be walking through a city in a dream. Then something unusual happens. Perhaps gravity feels different, or a building changes shape. In a normal REM dream, this would pass without question. But in lucid REM, the frontal systems re-engage just enough to trigger reflection. That's strange. Then, wait, I'm dreaming. Once that thought forms, the experience changes. The dream does not vanish. The imagery remains. But the relationship to the imagery shifts. The dreamer becomes aware of being the experiencer. Research suggests that this increased frontal and parietal engagement may also support a stronger sense of self-location within the dream. The dreamer knows they are inside a mental construction. The environment feels internally generated rather than externally imposed. However, this reactivation is partial. The emotional systems of REM remain active. The imagery remains immersive. The body remains in REM atonia. That is why lucid dreaming can feel so unusual. It is not fully waking. It is not fully ordinary dreaming. It is awareness layered into the dream state. The idea of the manager returning is only a metaphor, but it helps illustrate the balance. The brain does not completely switch modes. Instead, certain supervisory systems come back online just enough to monitor the experience. Sometimes that monitoring remains steady. The dream becomes stable. The dreamer explores while knowing it is a dream. Sometimes the monitoring fades. The frontal activity decreases again. The dreamer is pulled back into automatic immersion. This instability is part of the nature of lucid REM. The state is balanced between reflection and absorption, between observation and participation. The increased frontal and parietal activity does not replace the dreaming networks, it overlays them. It adds a thin layer of self-awareness to an otherwise immersive state. That is why lucidity can feel like waking up without actually waking up. Lucidity can feel like waking up without actually waking up. Here's the simple superpower behind lucidity: metacognition. The word sounds technical, but the idea is gentle and familiar. Metacognition means thinking about your own thinking. It is the ability to step back from an experience and notice it, to observe your own mental state instead of being fully absorbed in it. During waking life, metacognition helps you check reality. If you mishear someone, you pause and reconsider. If a memory feels uncertain, you reflect on it. If something seems unlikely, you question it. That quiet ability to monitor your own mind is active throughout the day. But during normal REM dreaming, that monitoring ability becomes softer. The brain is generating imagery. Emotional centers are active. Scenes unfold quickly. But the systems that evaluate and reflect are less engaged. The dream is experienced directly, without commentary. You're inside it, not observing it from outside. Lucid dreaming involves the partial return of metacognition. Instead of moving automatically through the dream, you notice your state. You recognize that what you are experiencing is internally generated. The mind becomes aware of itself. It is a subtle shift. The dream does not have to change first. There does not have to be a dramatic event. Sometimes the realization comes quietly. A small detail feels unusual. A pattern seems inconsistent. A question forms. And then the awareness settles in. I am dreaming. That sentence is metacognition in action. It is not simply seeing the dream. It is recognizing the nature of the experience. During waking life, metacognition helps you maintain stability. It allows you to compare perception to memory. It supports reasoning. It helps you correct errors. During lucid REM, that ability returns just enough to recognize the dream state. Research suggests that lucid dreamers may show stronger metacognitive abilities overall, even during waking life. Some studies have found correlations between frequent lucid dreaming and better performance on tasks that measure reality monitoring. Reality monitoring is the ability to distinguish between something imagined and something actually perceived. This does not mean lucid dreamers are fundamentally different, but it suggests that the capacity for self-reflection may influence how easily lucidity emerges. In REM, working memory is usually reduced. Working memory allows you to hold information briefly in mind. It helps you remember what you were just thinking. It supports complex reasoning. When working memory is lowered, thoughts move fluidly without being held in place. In lucid REM, working memory appears to increase slightly compared to normal REM. This may allow the dreamer to maintain the thought, "I am dreaming," instead of losing it immediately. It may also allow the dreamer to follow simple plans inside the dream. But metacognition in lucid dreaming is often unstable. Because the brain remains in REM, the networks that support immersive dreaming are still active. Emotional systems continue to generate intensity. Visual imagery continues to flow. The reflective layer can weaken again. Awareness can fade. Lucidity is not always steady. It can fluctuate. You may realize you are dreaming. then become absorbed again, then realize once more. This instability reflects the balance between reflection and immersion. The brain is still operating within the REM state. The dream networks remain powerful. Metacognition adds perspective, but it does not fully override the dream machinery. There is something gentle about this. Lucidity is not a dramatic takeover of the dream. It is a quiet recognition. The mind notices its own activity. It sees that the world it is walking through is constructed from memory and imagination. And yet, the world remains vivid. The ground still feels solid beneath your feet. The sky still stretches above. The characters still speak. Metacognition does not erase the dream. It reframes it. It allows you to experience the dream and recognize it at the same time. In waking life, this ability feels ordinary. You constantly monitor your thoughts without noticing that you are doing it. In lucid dreaming, the same ability feels extraordinary because it appears inside a world built from sleep. The return of metacognition is what separates a lucid dream from an ordinary one. It is not control. It is not brightness. It is not intensity. It is recognition. Lucidity is not just seeing a dream. It's recognizing your own state. Most dreams don't get interrupted by logic. You might be flying without wings, walking through walls, having a conversation with someone who looks different from moment to moment. And yet, while you are inside the dream, you rarely stop to question it. Why? To understand that, we return to how the brain behaves during normal REM. During ordinary REM dreaming, reality testing is weaker. Reality testing is the process your brain uses during waking life to compare experience against memory, logic, and external evidence. It is how you confirm that something is truly happening in the outside world. When you're awake, this system runs quietly in the background. If something strange occurs, your brain checks it. If gravity suddenly disappeared while you were standing in your kitchen, you would immediately know something was wrong. The frontal regions of the brain would evaluate the event against your stored understanding of physics and experience. In normal REM, that monitoring system is softened. The brain is generating the environment internally. There is no outside sensory input to compare against. The visual scenes come from memory and imagination. The sounds are constructed internally. The physical sensations are simulated. Because the dream is internally generated, the brain treats it as the current world. There is no competing input from the outside to contradict it. Without strong frontal monitoring, contradictions do not trigger alarms. A hallway turns into a forest. A friend becomes a stranger. The sky changes color. The story shifts without warning. Instead of stopping to analyze the inconsistency, the mind adapts. It continues. Part of this comes from reduced activity in areas linked to self-reflection and evaluation. When those networks are quieter, the experience flows uninterrupted. The dream feels immersive because it is not being constantly questioned. Memory context also plays a role. In waking life, your sense of reality is supported by continuous memory. You remember where you were 5 minutes ago. You remember how you arrived at your current location. That ongoing thread creates stability. In REM, memory context is thinner. You may not remember falling asleep, you may not remember how you arrived in the dream scene. The story begins in the middle. Events simply are. Without strong memory anchoring, the dream feels self-contained. It does not need a detailed backstory to feel real. The brain accepts the present moment as the whole environment. This combination, reduced reality monitoring and limited contextual memory, makes dreams convincing. It is not that the brain is incapable of logic. It is that logic is not prioritized during REM. The mind becomes fluid. Associations form freely. Emotional tone guides the narrative more than factual consistency. The dream operates under its own rules. Lucidity often begins when something feels off enough to notice. Perhaps the dreamer sees their reflection and it looks distorted. Perhaps they attempt to read text and it changes repeatedly. Perhaps the environment shifts in a way that draws attention. In that moment, reality testing briefly reactivates. Instead of accepting the inconsistency, the brain questions it. And that question is the doorway to lucidity. But most of the time, that question does not arise. The emotional and visual systems are strong. The monitoring systems are softer. The dream continues uninterrupted. This is why even very strange dreams can feel completely normal while they are happening. The brain is not comparing the experience to waking standards. It is operating within its internally generated world. The absence of strong frontal evaluation does not make dreams chaotic. It makes them immersive. You participate fully because you are not stepping outside the experience. Only when monitoring returns, even partially, does the mind step back. And stepping back is what creates lucidity. Until then, the dream flows. The hallway becomes a forest. The forest becomes a city. The city becomes a memory. And none of it feels impossible. A dream can be strange and still feel completely normal inside it. Lucidity often needs a tiny bit of memory to hold steady. When a person realizes they are dreaming, that realization does not automatically stay in place. It can fade quickly. The dream environment continues to shift. Emotional systems remain active. The brain is still in REM. For lucidity to remain stable, certain memory systems must briefly strengthen. One of those systems is reality monitoring. Reality monitoring is the ability to tell the difference between something imagined and something actually experienced. During waking life, this system runs quietly in the background. It helps you remember whether you truly said something out loud or only thought about saying it. It helps you distinguish between memory and imagination. Some research suggests that people who experience lucid dreams more frequently may show stronger reality monitoring abilities overall. They may be slightly better at distinguishing internally generated thoughts from externally generated events. During normal REM, however, working memory is usually reduced. Working memory allows you to hold information briefly in mind. It supports planning, counting, and maintaining a thought long enough to act on it. When working memory is lowered, thoughts move fluidly but do not stay anchored. Ideas shift quickly. The narrative continues without pause. In a typical REM dream, you may think something, but that thought does not stay long enough to build into reflection. The dream absorbs it and moves forward. In lucid REM, working memory appears to increase slightly compared to non-lucid REM. This increase does not fully restore waking cognition, but it may provide just enough stability for the thought, "I am dreaming," to remain present for more than a moment. That small difference matters. Lucidity often includes remembering a plan formed earlier. Some people, during waking life, set an intention. They tell themselves, "When I notice something strange, I will check whether I am dreaming." That intention relies on prospective memory, the ability to remember to do something in the future. Prospective memory is the system that reminds you to send an email later or take medicine at a certain time. It holds a goal in the background until the right cue appears. In lucid dreaming, prospective memory can be triggered inside REM. A strange event occurs, a pattern feels unusual, and the sleeping brain retrieves the intention. Check if this is a dream. Without that memory retrieval, the unusual event would pass unnoticed. With it, awareness emerges. Once lucidity appears, working memory helps maintain it. It allows the dreamer to remember what they just realized. It allows them to follow a simple goal, such as counting seconds, examining their surroundings, or observing the dream carefully. Laboratory studies have shown that lucid dreamers can perform tasks inside REM, such as signaling with their eyes at specific times, or counting internally before signaling again. These tasks require holding instructions in mind. That suggests that working memory is functioning at a higher level during lucid REM compared to ordinary REM. However, this memory stability is fragile because the brain remains in REM. The immersive networks continue to dominate. Emotional shifts can distract. Visual changes can pull attention outward. The reflective thought can dissolve. Lucidity fades when memory fades. The thought, "I am dreaming," must be remembered to remain active. If it slips away, the dream resumes its automatic flow. This is why lucidity often feels delicate. It requires a balance. The brain must maintain enough stability to hold the realization, but not so much that it fully wakes. Lucidity happens when the brain regains just enough organization to ask a question. Is this real? That question requires memory. It requires holding the present moment in mind long enough to compare it to waking knowledge. It requires remembering what waking reality feels like. It requires recalling the possibility that this experience could be a dream. In ordinary REM, those memory links are thin. The dream feels self-contained. There is no need to compare it to waking life. In lucid REM, those links briefly strengthen. The dream continues. The imagery remains vivid. The body remains still. But now the mind holds two layers at once: the dream itself and the memory of waking reality. That dual awareness is sustained by fragile memory systems, working just enough to maintain the realization. A lucid dream is partly about remembering to remember. This experience is more common than most people think. Lucid dreaming can sound rare or unusual at first. The idea of realizing you are dreaming while still asleep feels extraordinary. But when researchers ask large groups of people about their dream experiences, a consistent pattern appears. Around half of people report having at least one lucid dream at some point in their lifetime. That means this experience is not limited to specialists or dedicated practitioners. It does not require training It does not require study. For many people, it happens naturally once or twice across many years of sleep. The frequency varies widely. Surveys suggest that roughly 20 to 25% of people report having lucid dreams at least once a month. A smaller portion experience them weekly, and a much smaller group reports them several times per week. At the same time, many people have them rarely. Perhaps once in childhood, perhaps once in adolescence, perhaps never again. Lucid dreaming is widespread, but not evenly distributed. Researchers have also looked at age differences. Lucid dreams appear to be more common in childhood and adolescence. Younger people often report higher rates of lucidity compared to older adults. As people age, the frequency of lucid dreams tends to decline for many individuals. There are several possible reasons for this. Children often have more vivid and imaginative dream lives in general. They may have stronger fantasy engagement. Sleep architecture also changes across the lifespan. REM patterns shift. Deep sleep decreases with age. The balance of sleep stages evolves over time. Gender differences, however, are usually small or inconsistent in research findings. Some studies find slight differences. Others find none. Overall, lucid dreaming does not appear strongly tied to gender. Personality traits may play a more noticeable role. Studies have found associations between lucid dreaming frequency and openness to experience. Openness is a personality trait linked to imagination, curiosity, and creative thinking. Individuals who score higher on measures of openness often report more frequent lucid dreams. This does not mean that openness causes lucidity, but it suggests that cognitive style may influence how often the reflective systems activate during REM. Dream recall also matters. People who frequently remember their dreams are more likely to report lucid dreams. This may not mean they experience lucidity more often, only that they remember it when it happens. If a lucid moment occurs but fades before waking, and the dream is forgotten, it may never be reported. Strong dream recall increases the chance that lucid experiences are noticed and remembered the next morning. Some individuals report a handful of lucid dreams across their entire lifetime. Others report them occasionally during stressful periods, times of change, or phases of irregular sleep. Still others experience them with regularity and familiarity. The variation suggests that lucid dreaming is not an all-or-nothing trait. It exists on a spectrum. For some, it is a rare flicker. For others, it is an occasional event. For a smaller group, it becomes a recurring feature of sleep. Researchers continue to study why these differences exist. Brain structure, sleep patterns, personality traits, memory systems, and even cultural exposure to the concept of lucid dreaming may all influence how often lucidity emerges. Importantly, having lucid dreams does not automatically mean someone sleeps differently in a negative way. For most people, occasional lucid dreams are simply variations within normal REM patterns. They are part of the range of human sleep experience. When people hear that around half of individuals report at least one lucid dream, it reframes the concept. It is not rare in the sense of being extraordinary. It is unusual enough to feel special, but common enough to be considered part of natural sleep variation. the sleeping brain is flexible. Across millions of nights of human sleep, sometimes awareness stays fully immersed in the dream. Sometimes it flickers on, sometimes it fades again. The frequency of that flicker varies from person to person. Lucid dreaming is widespread, but not evenly shared. Lucidity has patterns across life, like many sleep traits do. Just as sleep changes with age, so does the likelihood of experiencing lucid dreams. The sleeping brain is not static across a lifetime. The structure of sleep shifts. Deep sleep decreases gradually in adulthood. REM cycles adjust. Memory systems mature and then change again with age. Lucid dreaming follows patterns within these broader changes. Research suggests that lucid dreams are more common in childhood and adolescence. Children often report higher rates of dream recall in general, and some studies indicate that spontaneous lucidity may occur more frequently in younger individuals. The developing brain is flexible, imaginative, and highly engaged in internal simulation. Emotional systems are active. Fantasy and reality can blend more easily. It is possible that this cognitive flexibility makes the boundary between immersion and reflection more permeable during sleep. Adolescence also appears to be a period where lucid dreaming may be relatively frequent for some individuals. During these years, self-awareness is developing rapidly. Reflection becomes more sophisticated. Identity formation is underway. The brain is still highly plastic. As adulthood progresses, the frequency of lucid dreams tends to decline for many people. This does not mean they disappear entirely, but surveys often show lower reported rates among older adults compared to younger populations. There are several possible explanations for this pattern. Sleep architecture changes with age. Deep sleep becomes shorter. REM patterns shift. Overall sleep may become lighter or more fragmented in later adulthood. Memory recall also changes over time. Because lucid dreaming requires remembering the experience upon waking, differences in recall can influence reported frequency. Cognitive style may also play a role. Adults often develop more stable and structured thinking patterns. The balance between imagination and evaluation may shift compared to childhood. Gender differences, however, are usually small or inconsistent in research findings. Some surveys suggest minor differences in frequency. Others find none at all. Overall, lucid dreaming does not appear strongly tied to gender in a consistent way across studies. Personality traits seem to show stronger associations. One trait that repeatedly appears in research is openness to experience. Openness is linked to imagination, curiosity, creative thinking, and comfort with abstract ideas. Individuals who score higher in openness often report more frequent lucid dreams. This does not mean openness causes lucidity, but it suggests that cognitive style matters. A mind that easily entertains unusual ideas may be more likely to question a dream environment. A person who naturally reflects on internal experiences may be more likely to notice the dream state. Another important factor is dream recall. Frequent lucid dreamers often have stronger dream recall overall. They remember their dreams more clearly and more often. This may increase the chances of recognizing patterns within dreams. It also increases the likelihood that lucid moments are remembered upon waking. Dream recall itself varies widely across individuals. Some people wake with detailed narratives almost every morning. Others rarely remember anything from the night. Memory consolidation plays a role. Attention to dreams during waking life can influence recall. Simply thinking about dreams more often can make them easier to retrieve. This does not create lucidity directly, but it creates familiarity with the dream landscape. And familiarity may support recognition. Vivid imagery also appears linked to lucid dreaming frequency. People who naturally experience strong visual imagination during waking life may also have more immersive dream imagery. That vividness can make unusual details stand out more clearly, increasing the chance that reflection arises. Still, variation remains wide. Some individuals report a single lucid dream in their lifetime. Others report them a few times per year. A smaller group experiences them monthly or even weekly. The distribution is uneven. Lucid dreaming is not a fixed trait like eye color. It exists on a spectrum shaped by age, personality, sleep structure, and memory patterns. The sleeping brain is flexible across life. In childhood, imagination and fluid thinking may make lucidity more likely. In adulthood, stable cognitive patterns may reduce spontaneous frequency for some. Personality traits like openness may influence how often reflection arises during REM. Strong dream recall increases the chance that lucid moments are noticed and remembered. All of these factors interact quietly beneath awareness. Lucidity does not belong to one group of people. It appears across ages, across personalities, across cultures. But it does not appear equally for everyone. Some brains remember dreams like postcards, brief and faded. Others remember them like full movies, detailed and immersive. And in those fuller landscapes, recognition sometimes emerges. For a long time, lucid dreams sounded impossible to measure. If someone claimed they became aware inside a dream, how could that be verified? Dreams happen behind closed eyes. The body is still. The person cannot speak. The experience disappears upon waking. For centuries, lucid dreaming remained a personal report, something described in journals, letters, and stories, but not something that could be observed in a laboratory. The challenge was simple. How do you communicate from inside a dream? In the late 20th century, researchers found a solution. During REM sleep, most of the body is in a state of muscle atonia. The arms and legs are effectively offline, prevented from moving, so that dreams are not physically acted out. But one system remains active: the eyes. Even though the eyelids are closed, the eyes still move beneath them during REM. These rapid movements are visible on sleep recordings. They can be measured using a device called an electrooculogram, or EOG. Electrodes placed near the eyes detect shifts in electrical potential when the eyes move left or right. Researchers realize something important. If a person inside a dream intentionally moved their eyes in a specific pattern, that pattern might appear clearly on the recording equipment. So lucid dreamers were trained. Before sleep, participants agreed to perform a deliberate eye movement sequence once they realized they were dreaming. For example, they might move their eyes left, right in a distinct pattern. This sequence would not occur randomly. it would stand out against normal REM eye activity. Then they went to sleep in the laboratory. When REM sleep began, researchers watched the recordings carefully. At some point during the REM period, a clear, deliberate left-right signal appeared on the EOG trace. The brainwave pattern showed the person was still fully in REM sleep. Muscle tone remained low. There was no sign of awakening. Yet the eye signal had occurred. After waking, the participant reported becoming lucid and intentionally signaling the researchers. The timing matched. The signal on the recording corresponded to the reported moment of lucidity. This was a turning point. It demonstrated that lucidity can occur while the brain is in genuine REM sleep, not during partial awakening. The person was not confused. They were not awake. They were dreaming and aware. One of the researchers most associated with this work is Stephen LaBerge, who conducted pioneering experiments in the 1980s. His studies helped bring lucid dreaming from philosophical discussion into measurable science. The eye movement signaling method was elegant because it used a system that remains active in REM. The dreamer could not speak, the body could not move, but the eyes could still communicate. This method also allowed for timing experiments. Once researchers could detect the moment lucidity began, they could ask participants to perform tasks inside the dream and signal when they started and finished. These signals created measurable markers on the sleep record. The findings were consistent. Lucid dreamers could intentionally produce eye signals during REM sleep. The signals appeared while the EEG showed clear REM patterns. The person remained asleep throughout. This proves several important points. First, lucid dreaming is not a myth or exaggeration. It is a verifiable brain state. Second, awareness can exist within REM sleep without causing full awakening. Third, communication from inside a dream, at least in limited ways, is possible. The dreamer could not speak, so they spoke with their eyes. This simple but powerful method changed how lucid dreaming was understood. It allowed the phenomenon to move from anecdote into experiment. It allowed researchers to explore timing, physiology, and brain activity during lucid episodes. What once sounded impossible became measurable. A person, fully asleep, inside a dream world generated by their own brain, could send a signal outward to the waking laboratory. The boundary between sleeping and waking, it turned out, was not as rigid as once believed. Lucidity lives in that boundary. Still dreaming, still in REM, but aware and able to gently signal from within. Once eye signals worked, researchers started asking a new question. If a lucid dreamer can signal from inside a dream, can they also perform tasks that match real-world timing? In other words, does time inside a lucid dream move at the same pace as time outside the dream? This question matters because dreams often feel distorted. In ordinary dreams, events can skip forward. Scenes can shift without transition. Hours can seem to pass in moments, or long stretches of story can feel compressed into seconds. Lucid dreaming offered a way to test this. Researchers asked lucid dreamers to signal the beginning of a task with a specific eye movement pattern. Then, inside the dream, they would perform a simple activity, such as counting to 10, or walking a certain number of steps, and signal again when finished. The eye signals created clear markers on the laboratory recordings. Between those signals, researchers measured how much real-world time had passed. The results were surprisingly steady. In many experiments, counting tasks inside lucid dreams matched real time closely. If a dreamer counted to 10 at a normal pace inside the dream, about 10 seconds passed on the recording. If they counted to 30, roughly 30 seconds passed outside. This suggested that, at least for simple mental tasks, dream time in lucid REM is similar to waking time. The dream world may feel fluid and unstable, but the internal sense of seconds ticking forward appears anchored to the brain's real physiological timing. Not all tasks matched perfectly. Some imagined movement tasks, like performing physical actions, took slightly longer in dreams than in waking life. This may reflect differences in how the motor system simulates action during REM. Because the body is under muscle atonia, the motor commands are generated but not carried out. The simulation may run at a slightly altered pace. Still, the overall pattern remained clear. Lucid dreamers could start and stop tasks deliberately. They could signal those moments with eye movements, and the measured time between signals closely resembled waking time. Researchers also observed physiological changes during lucid moments. Heart rate could increase. Breathing patterns could shift. Emotional intensity could produce measurable responses in the autonomic nervous system. These changes were recorded while the EEG continued to show REM sleep. Importantly, producing eye signals did not automatically wake the dreamer. The signals occurred within REM. The brain remained in its characteristic pattern. Muscle tone stayed low. The sleeper did not transition into full wakefulness simply because they performed a deliberate action inside the dream. This reinforced the idea that lucid dreaming is a genuine state within REM sleep, not a brief awakening misinterpreted as dreaming. The timing studies added another layer of evidence. Dream experiences are subjective, but timing can be measured. When dreamers signaled the start and end of counting, researchers could see the seconds pass on the recording. When they imagined movements, the durations could be compared to waking baselines. Lucid dreaming became something that could be tested gently from the outside. The person in the bed remained asleep. Electrodes quietly recorded brainwaves and eye movements. In the laboratory, researchers watched for signals. Inside the dream, the participant counted, walked, or completed a simple task. Two worlds running at once. One internal and imagined. One external and measured. The signals bridged them. These experiments helped answer a long-standing question about dream time. While dreams can feel distorted in memory, the underlying timing mechanisms of the brain continue to operate in real-world rhythm. Seconds still pass at the pace of seconds. The brain's internal clock does not stop simply because it is dreaming. Lucid dreaming made that visible. A lucid dream can be measured gently from the outside. Here's a key truth that surprises people. Lucidity means awareness, not automatic control. When many people first hear about lucid dreaming, they imagine total freedom, flying anywhere, changing landscapes instantly. rewriting the dream like a movie director. And while control can happen in lucid dreams, it is not guaranteed. In fact, awareness and control are two separate processes inside the brain. Lucidity is the recognition, I am dreaming. Control is the ability to intentionally change what happens next. These two do not always arrive together. In many lucid dreams, the dream continues unfolding on what feels like autopilot. The dreamer knows they are dreaming, yet the environment still shifts. Characters still act on their own. The story moves forward without clear direction. Why? Because lucidity happens within REM. The dreaming brain remains active. Emotional centers are still engaged. Visual imagery systems continue building scenes. The underlying machinery of dreaming does not shut off simply because awareness returns. The brain has added a layer of reflection, but it has not handed over full executive control. Dream control appears to involve additional engagement of frontal brain regions. The more stable the reflective networks become, the more influence the dreamer may exert. But these networks are still operating within a sleep state. They are not as strong as during full wakefulness. That makes control unstable. A dreamer may decide to fly and briefly succeed. The body lifts from the ground. The sky opens. Then doubt appears. The scene flickers. The ground returns. Confidence seems to matter. Studies and self-reports suggest that stronger belief in control often correlates with more stable dream manipulation. If the dreamer expects something to work, it is more likely to occur. If uncertainty appears, the scene may resist or collapse. This reflects how dreams are built. Dream environments are constructed from memory fragments, emotional tone, and expectation. The brain predicts what should happen next based on internal models. In waking life, sensory input constrains those predictions. In dreams, internal expectation has more influence. But expectation is not the same as control. Lucidity creates awareness. Control requires sustained attention and confidence inside a fragile simulation. Many lucid dreams still feel partially guided by the brain's own narrative flow. The dreamer observes events more clearly, but does not fully command them. Characters may respond unpredictably. Scenes may shift abruptly. The world may change without warning. Control can fade even while awareness remains. And sometimes awareness fades first. Lucidity itself can destabilize the dream. Becoming too excited, too focused, or too analytical can increase arousal. The dream may dissolve. The person may wake. Other times, the dream simply drifts. The reflective layer weakens. Immersion returns. The thought I am dreaming slips away, and the dream resumes its automatic course. It is important to separate awareness from power. Lucidity is about knowing. Control is about directing. You can know you are dreaming and still walk through a landscape you did not design. You can be aware and still watch the story unfold. Some lucid dreamers describe this as freeing. They do not try to change anything. They simply observe with curiosity. The dream becomes a space for exploration rather than control. Others attempt deliberate changes. Sometimes they succeed. Sometimes the environment resists. Sometimes the dream transforms in unexpected ways. The instability of control makes sense within brain science. REM sleep is still dominant. Emotional and visual networks are strong. Frontal regulation is partially active, but not fully online. The system remains balanced between immersion and reflection. The dream can resist because the simulation is not entirely under conscious command. It is a collaboration between sleeping networks and reflective awareness. Understanding this difference prevents confusion. Lucidity does not guarantee superhuman ability inside a dream. It guarantees recognition, and recognition alone is powerful. You can be awake inside the dream and still not be the director. Dream worlds don't have the same anchors as real life. When you are awake, the world feels stable. A chair stays where it is. A building does not dissolve into a forest. The people around you remain physically consistent. This stability comes from continuous sensory input. Your eyes send steady information. Your ears confirm space and distance. Your body senses gravity and balance. In dreams, especially during REM, those anchors are gone. The brain is no longer receiving strong external sensory input. Instead, it generates the environment internally. The sights, sounds, and sensations come from memory networks, emotional patterns, and stored experiences. Dreams are built from recombination. The hippocampus, a structure deeply involved in memory, helps stitch together fragments from different times and places. A childhood home can merge with a recent conversation. A familiar street can blend with a place you saw in a movie. Faces can shift subtly because the brain is blending stored representations rather than rendering a fixed photograph. Because these scenes are assembled from flexible memory networks, they are inherently unstable. There is no physical object anchoring them in place. There is only ongoing neural activity. Without strong reality filtering, bizarre shifts are common. During waking life, frontal brain regions constantly check incoming perception against stored knowledge. If something changes suddenly in front of you, your brain investigates. It stabilizes interpretation. In normal REM dreaming, this filtering system is quieter. The dream environment flows freely. If a door opens into a completely different landscape, the mind often accepts it without protest. The narrative continues. Places and people can change without warning. You may look at someone twice and see a different face. You may return to a room and find that its layout has transformed. You may begin walking down a hallway and emerge somewhere entirely unrelated. This is not a flaw in dreaming. It reflects the brain's method of simulation. The dream is not rendering a physical world with fixed coordinates. It is generating a story-like environment driven by association. When one memory activates another, the setting can shift to match. Lucidity can sometimes stabilize a scene, but not always. When awareness returns, frontal regions become more engaged. This can increase attentional focus. The dreamer may examine details more closely. The scene can feel clearer or sharper. Some lucid dreamers report that looking carefully at objects makes them appear more stable. But even in lucid dreams, the underlying REM processes continue. The simulation remains delicate. If attention drifts, the environment can morph again. If expectation changes, the landscape may follow. The dream responds quickly to internal shifts. This rapid change can feel disorienting, but it also reveals something important about how the brain constructs reality. Even in waking life, perception is not a direct recording of the outside world. It is an interpretation generated by the brain based on sensory input and prior knowledge. In dreams, sensory input is largely absent. The brain runs the predictive system on its own. The result is fluid. In waking life, external input corrects and stabilizes prediction errors. In dreams, there is nothing to correct them. The simulation updates itself based only on internal activity. That is why dream worlds can transform so easily. A single thought can alter the scene. A fleeting emotion can darken the sky. A memory fragment can become a building. The brain is constantly recombining elements. In lucid dreaming, awareness may briefly slow this process. Attention can anchor details. The dreamer can focus on textures, colors, or movement. This focus may increase stability for a short time, but the system remains fragile. If emotional intensity rises too quickly, the dream may destabilize. If attention scatters, the scene may blur. If arousal increases, awakening may follow. Dream worlds are simulations, beautiful, immersive, and vivid, but delicate. They are not held in place by gravity, mass, or physics. They are held in place by ongoing neural firing patterns. When those patterns shift, the world shifts. And this is not chaotic randomness. It is memory at work. It is association unfolding. It is the brain testing possibilities in a landscape free from external constraint. In that landscape, change is natural. A dream world is a simulation, beautiful but delicate. Many people describe lucid dreams as unusually bright and clear. Even compared to ordinary dreams, lucid experiences are often reported as sharper, more detailed, and more intense. Colors may seem richer. Edges may feel more defined. The air may appear clearer. The world can feel almost hyper-real. This does not mean every lucid dream is vivid, but vividness is one of the most commonly reported features. During REM sleep, the visual areas of the brain are already highly active. EEG patterns during REM resemble waking activity more than deep sleep. The occipital regions, which process visual information, are engaged even though the eyes are closed and no external light is entering. In lucid REM, that visual activity remains strong. At the same time, parts of the frontal and parietal regions involved in awareness become more active compared to ordinary REM. This combination may enhance the subjective clarity of the dream. The imagery is already vivid. The added layer of awareness allows the dreamer to examine it more closely. Attention sharpens perception. When you are awake and focus carefully on a scene, details become more noticeable. In lucid dreaming, that focused attention can increase the feeling of realism. The dreamer may look at their hands, examine textures, or study the environment. This focused observation can make the scene feel especially detailed. Colors are often described as intense. Some lucid dreamers report that reds appear deeper, blues appear brighter, light seems luminous. This may reflect the strong activation of visual networks combined with emotional intensity. Emotional centers, such as the amygdala, remain active in REM. Emotion and perception are tightly linked. When emotional tone is high, sensory experience can feel amplified. Tactile sensation can also feel real. People describe the feeling of wind, warmth, or touch. The sensation of walking can feel grounded. The experience of flying can feel physically convincing. Although the body is under muscle atonia, the brain's somatosensory regions can simulate physical experience with remarkable detail. The brain does not need external input to generate sensation. It uses internal models. In waking life, those models are guided by sensory data. In dreams, they are guided by memory and prediction. The result can feel authentic because the same neural circuits are involved. Emotion is another important part of vividness. Lucid dreams often lean more positive when the dreamer feels some stability or control. Realizing that one is dreaming can reduce fear in a nightmare. It can replace anxiety with curiosity. The emotional shift can make the environment feel brighter or more welcoming. However, emotional intensity can also increase vividness in other directions. Excitement, surprise, or awe can heighten the sense of realism. Because the limbic system remains active in REM, emotional tone is strong. Some research has examined substances that may influence vividness and lucidity rates. Galantamine, a compound that affects acetylcholine levels, has been studied in controlled settings. Acetylcholine is already elevated during REM. Increasing it further under certain conditions appears to raise the likelihood of lucid dreams and increase reported vividness in some participants. It is important to note that such studies are conducted under controlled conditions and are not recommendations. They simply demonstrate that neurotransmitter balance influences dream intensity. The chemistry of REM supports vivid imagery. Lucid dreaming does not exit that chemistry. It operates within it. Because awareness returns, dreamers sometimes describe the experience as more real than real. This phrase reflects subjective intensity, not objective comparison. The clarity feels striking because attention is fully engaged, while external distractions are absent. There is no background noise, no physical discomfort, no competing sensory input. The brain simulation fills the entire field of experience. That immersive quality can feel heightened when awareness turns on. But vividness varies. Some lucid dreams are soft and hazy. Some are bright and sharp. Stability, emotional state, and level of attention all influence how clear the environment feels. The important point is this: lucid dreams are not dull. They occur in a brain state already rich with imagery and emotion. The added layer of reflection can make that richness more noticeable. In a lucid dream, the senses can feel turned up, like a vivid screen glowing in the dark. Sometimes the line between dreaming and waking gets thin. Most of the time, sleep stages transition smoothly. You fall asleep. You cycle through lighter and deeper phases. You enter REM. You return toward lighter sleep. Eventually, you wake. The shifts are quiet and orderly. But occasionally, the boundaries overlap. Sleep paralysis can occur when REM atonia continues into wakefulness. During REM, the brain activates strong muscle inhibition. This motor lock prevents you from physically acting out dreams. It is protective and automatic. The body rests while the brain simulates movement. Normally, when you wake up, this muscle inhibition switches off almost instantly. In sleep paralysis, that switch lags. The brain regains awareness before the body regains movement. The person may feel fully awake. They may see their bedroom clearly. They may hear sounds in the room, but they cannot move their arms or legs. The chest can feel heavy because breathing during REM is automatic and somewhat shallow. The inability to move can create fear. And because dream imagery systems are still partly active, visual or auditory hallucinations can blend into the waking environment. This is not a supernatural event. It is a state overlap. REM-linked body effects remain active while awareness returns. Lucid dreaming and sleep paralysis can feel connected for some people because both involve awareness during REM-related processes. In lucid dreaming, awareness turns on while the dream continues. In sleep paralysis, awareness turns on while REM atonia is still present. The difference lies in whether the dream world is still immersive. In lucid dreaming, the person remains within the dream landscape. In sleep paralysis, the person feels awake in their real environment, but still carries remnants of dream imagery or body paralysis. For some individuals, sleep paralysis can transition into a lucid dream. If the person remains calm and allows imagery to form, the dream scene may build around them. The paralysis becomes part of the shift back into full REM dreaming, this time with awareness. For others, sleep paralysis remains a brief and intense waking episode. Both experiences highlight how flexible sleep states are. They are not rigid compartments. The brain can move gradually from one state to another. Sometimes those movements overlap. False awakenings can add to this blending. A person may dream that they woke up. They may sit up in bed, look around, and believe they are fully awake, but they are still dreaming. Then they wake up again and again. These layered awakenings can create confusion. Am I awake yet? Because lucid dreaming involves questioning reality, it can intersect with false awakenings. A person may recognize that they are dreaming after a false awakening, or they may wake into sleep paralysis and feel uncertain about their state. These experiences are usually temporary. Sleep paralysis episodes typically last seconds to a couple of minutes. They end when the brain fully transitions into wakefulness or back into sleep. Lucid dreams also tend to be brief, often lasting only part of a REM period. But during the experience, the intensity can feel strong. The inability to move can trigger anxiety. The blending of dream imagery with the real room can feel startling. The sense of being between states can feel strange. Understanding the mechanism reduces fear. REM atonia is protective. Awareness returning early is not dangerous. The brain is simply shifting states. Studies suggest that sleep paralysis is relatively common. Many people experience it at least once in their lifetime. It can be more frequent during irregular sleep schedules, stress, or sleep deprivation. It is also more common in adolescence and young adulthood. Lucid dreaming itself does not cause sleep paralysis, but because both involve awareness during REM-related processes, people who are familiar with one may become more aware of the other. The key point is that these are natural variations within the sleep cycle. The brain can move gradually from REM to wakefulness. Sometimes that transition is seamless. Sometimes it overlaps. Awareness may turn on before muscle tone returns. Dream imagery may linger as the eyes open. The edges can feel thin, but they are edges within a normal system. Sleep is dynamic. It is a series of coordinated changes in brain activity, chemistry, and body control. Most nights, those changes flow smoothly. Occasionally, they overlap in noticeable ways. When that happens, the experience can feel unusual, even intense. But it remains part of the same underlying architecture. The brain can shift states, and the edges can feel strange. Sometimes you wake up inside a dream, and it feels completely normal. You sit up in bed. The room looks familiar. The light is just as it should be. Maybe you reach for your phone. Maybe you walk to the bathroom. Everything feels ordinary. And then something shifts. You realize you are still dreaming. This is called a false awakening. A false awakening is a dream in which you believe you have woken up. The mind simulates the act of waking. The environment often mirrors your real bedroom. The details may be convincing. The placement of furniture, the position of a window, the feeling of sheets against your skin. Because the setting is familiar, it feels real. False awakenings are common in REM. During REM sleep, the brain is capable of constructing detailed, emotionally convincing scenes. It can simulate routines. It can replay habits. Waking up is one of the most familiar routines your brain knows, so it can recreate it. In a false awakening, the dream does not feel dramatic. It feels normal. You may check the time. You may brush your teeth. You may start your morning tasks. Only later does something unusual appear. A clock displays inconsistent numbers. A door leads somewhere impossible. A reflection looks distorted. Sometimes that odd detail triggers lucidity. The dreamer realizes, this isn't right. I'm still asleep. False awakenings can therefore correlate with lucid dreaming. They create an opportunity for reality testing. The setting feels realistic, but small inconsistencies can stand out. If the reflective systems engage, lucidity emerges. But false awakenings do not always lead to awareness. Often, the dream simply continues. A chain of false awakenings can happen. You dream that you wake up. Then you dream that you wake up again. Each time, the scene resets to the bedroom or morning routine. Each time, it feels convincing. When you finally wake for real, there can be brief confusion. Am I truly awake now? This short-lived uncertainty reflects how accurately the brain can simulate waking life. The same visual areas are active. The same spatial memory networks reconstruct the room. The same motor plans are rehearsed. From the brain's perspective, waking is just another modeled state. In predictive brain theories, the mind is constantly generating models of the world. During waking life, those models are corrected by sensory input. During dreaming, especially in REM, the models run without external correction. Waking can be modeled too. The brain can simulate the feeling of opening your eyes. It can simulate standing up. It can simulate the sensation of morning light. Because REM is associated with strong imagery and emotion, false awakenings can feel detailed and immersive. They often occur toward the end of a REM period, when dreaming is vivid and sleep is lighter. That timing increases the chance that awareness is close to returning. Sometimes false awakenings blend with sleep paralysis. A person may wake up in the dream bedroom, but feel unable to move. In this case, the brain may be partially transitioning, while REM atonia remains active. Other times, false awakenings remain purely dream-based. The body stays asleep. The dream continues quietly. These experiences show something subtle but important. The brain does not draw a hard line between dreaming and waking. It can simulate both. It can move between them gradually. It can layer them. You can dream about dreaming. You can dream about waking. And you can wake from a dream about waking. For lucid dreamers, false awakenings can become familiar signals. If someone frequently practices reality testing, they may check their state upon waking. That check can reveal the dream. But for most people, false awakenings are occasional and brief. They are not signs of a problem. They are variations within REM dreaming. They demonstrate how thoroughly the brain can construct experience. Even the act of opening your eyes in the morning can be part of the dream narrative. The sleeping mind does not only build fantastical landscapes, it builds your bedroom, your routines, your morning habits, and sometimes it builds the feeling of waking itself. Even waking can be part of the dream story. People have tried many ways to increase lucidity, but science focuses on what can be tested. Lucid dreaming has inspired curiosity for centuries. Some approaches are philosophical, some are spiritual, some are anecdotal. But in laboratories, researchers narrow the field to methods that can be measured and repeated. The goal is simple. Can a specific technique increase the probability of lucidity during REM? Two of the most studied methods are called MILD and WBTB. MILD stands for mnemonic induction of lucid dreams. It is based on intention and prospective memory. Before falling asleep, a person repeats a phrase such as, "Next time I'm dreaming, I will remember that I'm dreaming." The idea is to plant a reminder in the mind, a cue that may activate during REM. This method relies on the same memory systems discussed earlier. Prospective memory allows a person to remember to do something in the future. In this case, the something is recognizing the dream state. WBTB stands for wake back to bed. This method involves sleeping for several hours, waking briefly, staying awake for a short period, and then returning to sleep. Because REM periods tend to lengthen later in the night, returning to sleep after several hours increases the likelihood of entering REM quickly. The combination matters. Research suggests that combining WBTB with MILD improves success rates compared to either technique alone. In controlled studies, participants who woke after about 5 hours of sleep, stayed awake briefly, practiced MILD, and then returned to sleep, were more likely to report lucid dreams during the following REM period. This does not guarantee lucidity, but statistically, the odds increase under those conditions. Some studies have explored cue methods as well. In these approaches, subtle light flashes or sound cues are delivered during REM. The idea is that the external signal becomes incorporated into the dream. For example, a flashing light might appear as flickering lamps in the dream environment. If the dreamer recognizes the unusual cue, it may trigger lucidity. Results for cue methods are mixed. In some cases, cues increase lucidity rates modestly. In others, they are ineffective or disrupt sleep. The timing must be precise. The signal must be subtle enough not to wake the person fully, but noticeable enough to appear in the dream narrative. Another area of research involves neurostimulation. Some studies have explored transcranial alternating current stimulation, TACS, at specific frequencies during REM sleep. Certain frequencies, such as those in the gamma range, have been associated with reflective awareness in waking states. In limited experimental setups, stimulation during REM has been linked to increased reports of lucidity. However, findings in this area vary. Replication is ongoing. The brain is complex, and subtle stimulation does not produce identical results across individuals. Galantamine has also been studied in controlled trials. Galantamine influences acetylcholine levels, a neurotransmitter already elevated during REM. In laboratory studies where galantamine was administered under controlled conditions, often combined with WBTB and MILD, lucid dream rates increased compared to placebo. It is important to emphasize that these studies occur under structured protocols. They are not casual experiments. They measure probability, not certainty. And they are not endorsements for unsupervised use. In scientific settings, lucidity is treated as a measurable outcome. Participants either signal lucidity or they do not. The frequency of signals is compared across conditions. Statistical differences are analyzed. The experience becomes data. What emerges from research is not a magic formula. It is a pattern. Lucidity is more likely when REM is abundant. It is more likely when intention and prospective memory are engaged. It is more likely when sleep is not overly fragmented. It is more likely when the reflective systems can briefly activate without full awakening. Importantly, repeated awakening attempts can fragment sleep. Frequent alarms, excessive stimulation, or prolonged wake periods can reduce sleep quality. Studies often note that the lucid dream itself is not the main issue. It is the disruption of sleep cycles that can carry consequences. In laboratories, induction is treated carefully. The focus remains on understanding the brain, not forcing experience. Lucidity is measured gently. Methods are evaluated systematically. Results are reported cautiously. The science of induction shows that lucidity can be nudged, but not commanded. In labs, lucidity is treated like a measurable outcome, not a magic trick. A calm topic also means being honest about limits and cautions. Lucid dreaming often sounds exciting. The idea of awareness inside a dream can feel empowering. But whenever a sleep topic becomes popular, it is important to slow down and look at what research actually says about safety. For most healthy individuals, current evidence suggests that lucid dreaming itself is generally safe. Lucid dreams occur during REM, a natural and recurring part of sleep. They do not represent a separate or artificial state. They are variations within the normal architecture of sleep. When lucidity happens spontaneously without deliberate disruption of sleep, studies do not show consistent harm to sleep structure. The experience itself, becoming aware inside a dream, does not appear to damage sleep cycles. However, induction attempts can fragment sleep if they involve repeated waking. Methods such as wake back to bed require setting an alarm and interrupting the night. If done occasionally and gently, this may not cause major issues, but frequent awakenings can reduce total sleep time. They can shorten deep sleep. They can create next-day fatigue. In sleep science, lost sleep is usually a bigger concern than altered dream content. Research suggests that the lucid dream itself is not the main problem. It is the repeated failed attempts, excessive alarms, or long wake periods during the night that can interfere with rest. Sleep works best when cycles flow naturally. Another concern sometimes raised is mental health. There is no clear evidence that lucid dreaming causes psychosis or severe mental illness in healthy individuals. Lucidity involves awareness and reflection, not loss of reality testing during waking life. In fact, lucid dreamers are often very aware that their experience is internally generated. However, caution is often advised for individuals already struggling with severe dissociation, unstable mood disorders, or psychotic symptoms. Because lucid dreaming involves altered states of awareness, professionals sometimes recommend focusing first on stable sleep patterns and mental health treatment before actively pursuing induction techniques. This is not because lucidity is inherently dangerous. It is because sleep and mental health are closely connected. Disrupted sleep can worsen underlying conditions. Prioritizing healthy sleep is always the first step. Another question researchers ask is whether frequent lucidity changes sleep architecture over time. Current data does not show consistent long-term harm from occasional lucid dreaming. REM cycles continue. Deep sleep remains present. Overall sleep efficiency appears largely intact in most studies. Lucid episodes are usually brief. They occupy part of a REM period, not the entire night. For many people, lucid dreams are rare events, a few times per year, perhaps once in a lifetime. For others who experience them more often, sleep patterns remain within normal ranges. Excitement during lucidity can sometimes trigger awakening. If awareness becomes too intense, the dream may collapse. The person may wake earlier than expected from that REM period. But waking from a dream is not inherently harmful. It is part of normal sleep variation. The greater risk comes from trying too hard. If someone becomes focused on achieving lucidity every night, repeatedly interrupts sleep, and sacrifices total rest, fatigue can accumulate. Concentration can suffer. Mood can shift. These outcomes are related to sleep loss, not to lucidity itself. The safest version is simple. Sleep first. Curiosity second. Healthy sleep habits, consistent schedule, limited stimulation before bed, adequate duration provide the foundation. Lucidity, when it appears naturally within that structure, is simply one expression of a flexible brain. It is also worth remembering that not everyone needs to pursue lucid dreaming. It is not required for creativity. It is not necessary for emotional processing. ordinary dreams already serve important functions in memory consolidation and emotional regulation. Lucidity is an interesting variation, not a goal that must be achieved. For most healthy adults, occasional lucid dreams fall within the wide range of normal sleep experiences. Sleep is resilient. REM cycles return. Deep sleep returns. The brain balances itself across nights. The evidence so far suggests that lucidity itself is not the danger. Disrupted sleep is. And sleep remains the priority. The safest version is simple. Sleep first, curiosity second. Tonight, we've moved through layers of sleep, from the steady rhythm of REM cycles to the body's built-in motor lock, from the chemistry that shapes vivid imagery to the small return of awareness that turns an ordinary dream into a lucid one. We've seen how the front of the brain can wake up just enough to notice, how memory can briefly stabilize the thought, "I am dreaming," how scientists measured eye signals in the dark and proved that awareness can exist inside sleep, how dream worlds shift because they are built from memory, not matter, and how even waking itself can be simulated inside a dream. Lucid dreaming is not magic. It is not mystical. It is not separate from sleep. It is sleep with a slight change in balance. The emotional systems remain active. The visual systems remain bright. The body remains safely still. But somewhere within that internal landscape, a reflective layer turns on. A quiet recognition appears. A small lamp inside a world made of sleep. And that lamp does not need to blaze. It flickers gently. Sometimes it fades. Sometimes it brightens. Sometimes it returns again within the same dream. It is a reminder that the brain can generate an entire world, and then notice that it has done so. Lucidity shows us something calm and simple about consciousness. The mind is not either awake or asleep in a strict line. It moves along a spectrum. Awareness can soften. It can strengthen. It can layer itself over imagination. It can observe its own creation. And yet, beneath all of it, the deeper rhythm continues. The cycles return. The body rests. The chemistry shifts back and forth in its steady pattern. Whether lucidity appears or not, sleep does its quiet work. Memory consolidates. Emotion settles. The nervous system recalibrates. Lucid dreaming is one variation within that larger process. It is not required. It is not necessary. It is simply possible. And sometimes, in the quiet of the night, that possibility becomes real. As you drift towards sleep now, there is no need to search for lucidity. No need to force awareness. The brain already knows how to move through its stages. It has done so thousands of nights before. If awareness turns on, it turns on. If it does not, that is just as natural. Because at its core, lucid dreaming is not about control. It is about recognition, and recognition can be soft. For now, you can let the thinking settle. Let the reflective layer dim. Let the internal world build itself however it chooses. The brain will continue creating, quietly, patiently, all through the night.